Hi everyone, for today's lesson, we are going to learn about the properties of exponents. You may have learned about the properties of exponents before, but we are going to be discussing them once again. Our learning objectives for today is for you to be able to say, I can simplify expressions using the properties of exponents. So for all of the properties of exponents that I'm going to describe today, I'm going to be working with variables a and b and variables m and n. Variables a and b are going to represent the bases of our exponential expression, and m and m are going to represent the exponents. Our bases are allowed to be real numbers, so any number that you can think of. We are not working with the value of I, so just real numbers. And m and n are going to represent integers. Integers are positive and negative whole numbers. So for each of the property, we are going to create an algebraic example. So the first one that we have is the product power property. And the product power, product happens after you multiply. If you multiply two powers with the same base, what you're going to do is you're going to rewrite this as that base raised to the m plus n power. You are going to add your exponents together. An example of this would be if you had x squared times x to the fourth power. This is equal to x to the sixth power. The reason for why this is true is because if you think about it, x squared is x times x, and x to the fourth power is x times x times x times x. And when you multiply these two expressions together, how many x's are you multiplying? 1, 2, 3, 4, 5, 6. This is x to the sixth power. So the shortcut is simply to add your exponents. 2 plus 4 is 6. Let's look at our next expression. This is called the power of a power. Power of a power property means that if you are having yourself an expression raised to an exponent, and then the whole quantity is raised to an exponent, instead of adding, you are going to multiply your exponents. Think of the distributive property. We would just simply multiply our exponents together. Here's a quick example of what that looks like. If I had x to the second power raised to the third power, this means x to the sixth power, because 2 times 3 is 6. The reason for why that is true is x squared to the third power really means x squared times x squared times x squared, in which we already know in this property up here that whenever you multiply powers with the same base, you add the exponents. 2 plus 2 is 4 plus 2 is 6. So therefore, the shortcut is simply to multiply your exponents together. 2 times 3 is 6. Next, we have the power of a product property. And the power of a product property means that if you have multiplication inside of your parentheses, you are allowed to distribute that exponent to each base, or to each exponents of each base. So that's going to be a to the mth power times b to the mth power. This is only a property that you are allowed to use if the main operation inside is multiplication. So you can only do this if there's multiplication only inside of the parentheses. So if there's addition inside of the parentheses, you are not allowed to distribute the exponent. Only if there's multiplication, only as the main operation inside of the parentheses. So a quick example of what this looks like would be something like 4x squared raised to the second power. What you would do is you would distribute, so technically every single number has an exponent, and that exponent is an invisible one, and you would distribute that exponent to each term. So this would be 4 squared times x to the second power, or sorry, x to the 2 times 2 power, which is the fourth power. So this is 16x to the fourth power. If you think about what this expression means, it means 4x squared times 4x squared, in which we would multiply our numbers together. 4 times 4 would give us 16. And we would multiply our variables together, in which we would add our exponents. 2 plus 2 is 4. And that's how you end up getting your answer. So we would distribute that exponent to each expression, or to each piece, to each base. Next, we have negative exponents. And a negative exponent means that, well, first of all, you're not allowed to have a negative exponent as a part of a final answer. So anytime that you see a negative exponent, we write the reciprocal of the base. So we essentially bring a down below the fraction bar. And so this is going to become 1 over a to the positive nth power. The same thing is true if we had a negative exponent on the bottom. Negative exponents are not happy where they're at, so you have to write the reciprocal of that base. And I have 2 examples for you for this type of problem. The first one is going to be x to the negative 5th power. X to the negative 5th power is not happy where it's at, so we bring it down to make it 1 over x to the positive 5th power. My next example for you is 3x to the negative 2nd. This is equivalent to, well, 3 has a positive exponent, so it stays where it's at, but x has a negative exponent, so we bring just that piece down to make it 3 over x squared. The positive exponents are happy where they're at. Negative exponents, they need to be switched. And I showed a switching motion of going down to up and up to down. And that's because what if I gave you 4 over x to the negative 2nd power? Well, 4 has a positive exponent, so it stays where it's at. But x to the negative 2nd is not happy where it's at, so we need to bring it up, making this 4x to the positive 2nd. So the nutshell is that wherever you see a negative exponent, we need to bring the entire base either up or down, depending on where it was originally located, and we change our exponent from being negative to now being positive. If you have a positive exponent, that power stays where it's at. It's happy. It's positive. Leave it alone. The next one is the zero exponent property. And the zero exponent property says that if you have a to the 0 power, the answer is automatically 1 as long as a does not equal 0. And this is where a does equal 0, something you're going to explore later on as you study mathematics. But for right now, I just need you to know that any craziness, and I'm going to give you like a crazy number, 2,456, x to the 4th, y to the 18th, z to the 275th, all of that to the 0 power equals 1. Anything to the 0 power is automatically 1. A lot of people like to write 0. Don't fall into that trap. Anything to the 0 power is 1. Next, we have the quotient of powers property. Quotient is what happens after you divide, and the quotient of powers property says that if you're dividing 2 powers with the same base, instead of multiplying or adding, instead we are going to be subtracting the top exponent minus the bottom exponent. So a quick example of what that would look like is if we had x to the 6th divided by x to the 4th. This is going to equal x to the 6 minus 4 power, which is going to be equal to x squared. Here's why this works. Technically, we would have 6 x's on top and 4 x's on the bottom. And we know that x over x is equal to the number 1. So that's 1, 1, 1, 1. And what we're left with are 2 x's on top. And x times x we know is x squared. This is one thing I want to emphasize, is that this answer is simply going to be x squared. I'm also going to write the reverse of this. What if this was x to the 4th power divided by x to the 6th power? Well, it's going to be top minus bottom, which is x to the negative 2nd, which, remember, you're not allowed to have negative exponents, so this is going to be 1 over x squared. The shortcut is to say, where are there more x's, on the top or the bottom? Well, there's more x's on the bottom, so that's where your value is going to go. 6 minus 4 is 2. There's more x's on the bottom, so x squared goes on the bottom. So if you can imagine the reciprocal of what I drew up here, we would have 4 x's on top, and we would have 6 x's on the bottom. The x's would all cancel away, but then we would be left with 2 x's in the denominator. In the numerator, we would have a placeholder of 1. So that's how you would end up with 1 over x squared. Because this is a lot to write out, especially if we're not dealing with nice numbers like 4 and 6, and we're dealing with 24 and 60, you don't want to draw out 24 x's and 60 x's. Instead, it just makes sense for us to use these properties and shortcuts to help us with these problems. Finally, we have the power of a quotient property, which means that if we have a fraction inside of a set of parentheses, we're going to distribute that exponent to each base in the numerator and the denominator. So this is going to be a to the nth power divided by b to the nth power. So in this problem, if you have 5 over x to the 3rd power, and this is raised to the 4th power, this is really going to be 5 to the 4th power divided by x to the 12th power. And 5 to the 4th power is 625 over x to the 12th. So we're distributing that exponent of 4 to each of the exponents. 1 times 4 is 4, so that's 5 to the 4th power. Not the number 54. I know it kind of looks that way with the way I wrote it. This is supposed to be 5 to the 4th power, which is 625. And then 4 times 3, which is 12. So those are all of our properties. And what I would like you guys to do at this time is I'm going to do some, and I would like you to please go ahead and complete the others. So the ones that I would like you guys to please go ahead and complete is I'm going to go ahead and do the first couple, like maybe example number 1, example number 4, and I'll do example number 6, and then I want you guys to complete the others for the next time that I see you. Maybe I'll do example number 5 because I know that one's tough for a lot of people. So looking at the very first one, we have 1 to the 4th over 3 to the 2nd. For this problem, it just depends on what you want to do. A lot of people like to just get started right away with distributing the exponent. Other times people just want to simplify what's inside of the parentheses. So it just depends on what you want to do and what you see. So to start this problem, I'm going to write 1 to the negative 8th power over 3 to the negative 4th power. Anything with a negative exponent is not happy where it's at, so I am going to bring anything with a negative exponent on top down, and anything with a negative exponent on the bottom up. And this is going to turn into 3 to the positive 4th power over 1 to the positive 8th power. 3 to the positive 4th power, that's going to be equal to it's going to be equal to 81, and 1 to the 8th power is equal to 1, because that's 1 times itself 8 times, and 81 over 1 is 81. Another approach is you could have recognized that this is really 1 over 9 raised to the negative 2nd power, and then distributed the exponent to each piece, but regardless, you would still end up with 81 as your answer. So it just depends on how you want to view the problem. You're not wrong regardless of which way you decide to go. Let's go ahead and look at example number 4. For example number 4, I see something with a negative exponent. I see a to the negative 3rd. It's not happy where it's at, so I'm going to bring it down. So therefore, I have b squared divided by a to the 3rd times a to the 5th. b to the second is going to stay on top. And anything that has the same base that where you're multiplying, we're going to add the exponents. So this is really a to the 8th power. Next we have example number 5. And with problems like these, the parentheses are here to confuse you. So I would recommend that unless you see an exponent on the outside of those parentheses, simply drop the parentheses. They're there to confuse you. So now I'm going to rewrite this as 7y squared, z to the 5th, y to the negative 4th, z to the negative 1st. If you want, you can rearrange your variables, or you can start combining. It just depends on what you want to do. So I see that this is really 7y squared times y to the negative 4th times z to the 5th times z to the negative 1st. So I rearranged my variables because remember, this is all multiplication in between all of these variables. And 4 times 5 equals 5 times 4. We know that order does not matter whenever we multiply. So I'm going to simply add my exponents. So I have 7y to the negative 2nd power times z to the positive 4th power. And all I did here was simply add my exponents. So now anything with a negative exponent, which in this case is just the letter y, 7 has a positive exponent, so it's going to stay where it's at. And I'm going to bring it down. So my answer is 7z to the 4th power all over y squared. And finally, I'm going to go ahead and do example number 6. For example number 6, I have a squared times b to the negative 1st all over negative 2, a to the 3rd, b to the 2nd power. And what I'm going to do to start this problem is I'm going to, instead of distributing the 3 to start, I'm going to simplify what's going on inside, and then I'm going to distribute the 3. So that's one approach. You could distribute the 3 to every exponent first, and then keep going. It just depends on what you want to do. So what I'm going to start off with is I notice that I have an a to the 2nd over an a to the 3rd. 3 minus 2 is 1. There's more a's on the bottom, so then that means I'm going to have, in my fraction, a negative 2 and an a. Then I'm going to subtract my b's. I have b to the negative 1st minus 2, so that's going to be negative 1 minus 2 is negative 3. And since there's more b's on the bottom, I'm going to have a b to the 3rd power on the bottom, with 1 being my placeholder raised to the 3rd power. If it helps you, you could bring that b to the negative 1st down, and we would have 2 plus 1 is 3. That's another way to view it. And now I'm going to distribute to all of my exponents the number 3. So this is going to be 1 to the 3rd power over negative 2 to the 3rd power times a to the 3rd power times b to the 9th power. So I put negative 2 into parentheses, and that's because it's going to be negative 2 times negative 2 times negative 2, which is going to make this a negative 8. So I'm going to have 1 over negative 8, a to the 3rd, b to the 9th. And if you want to rewrite this as just simply negative 1 over 8, a to the 3rd, b to the 9th, you can do that as well, just to make this whole fraction negative. All right, next what we're going, I want to say that was all of the examples that I had planned to do. The other examples of example 2, example 3, example 7, and example 8, I would like you guys to please go ahead and complete those on your own and be ready to discuss them for the next time that I see you in class. And that is the end of today's lesson. If you have any questions over anything that I talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.